Coming to you live from downtown England is Professor Wiley. Nah, I'm just kidding, guys. I'm not going to do an English accent. But we're going to talk about intervals of convergence today. So we're given the problem n equals 0 to infinity, the summation of that. And we're given the problem -1 to the n minus 1 times x minus 2 to the n divided by n times 4 to the n. And we are asked to find the interval of convergence. So, to do that, we're going to need to do the ratio test, and we're actually going to go ahead and ignore this -1 to the n minus 1 and just do it with x minus 2 to the n divided by n times 4 to the n. And so, for this ratio test, we're going to have a sub n plus 1 over a sub n. So x minus 2 to the n plus 1 is just going to be x minus 2 to the n times x minus 2. I went ahead and used a property there. And then substituting n plus 1, 4 to the n is 4 to the n plus 1. Again, using that property is the same thing as 4 to the n times 4. And then the bottom is just a to the n, so it's going to go ahead and just be the same equation. So I went ahead and reciprocated it, I flipped it, and we get this equation right here. And we can go ahead and start canceling things out. So x minus 2 to the n cancels with x minus 2 to the n, and it's going to go ahead and cancel to the n plus 1 because we're going to infinity here, so this plus 1 becomes negligible. This 4 to the n, again, cancels out with the 4 to the n. And basically, what we're left with is the absolute value, of x minus 2 divided by 4 is less than 1, which we're going to go ahead and multiply the 4 through, gives you the absolute value of x minus 2 is less than 4. So this is in the form that allows us to see the center of our interval of convergence as well as the radius. Our center is given right here. It's a -2, but that's actually going to translate to a +2 center, and it is a radius of 4, so we're going, if we think about a number line, with 2 being our center, we're going 4 in this direction and 4 in that direction. I went ahead and just did the basic math for you. 2 plus 4, we're going to have 6 and -2, meaning our interval is going to stretch from -2 to 6. So the next thing we need to determine actually is whether, given x, whether this is a less, and the 6 and the -2 are included or not included in this interval. To do that, we're going to go ahead and plug 6 and -2 back in separately and find whether that series converges or diverges. Plugging in the -2 into the original equation, it comes out to -4 to the n divided by n times 4 to the n. We can go ahead and take out a -1 to the n here, and that leaves -1 to the n times 4n divided by n times 4 to the n. Again, these 4 to the n's cancel, and we're left with -1 to the n divided by n. This is actually a common series known as the alternating harmonic series, and that we automatically know that it converges. Right? So moving on to 6, we are given 4 to the n divided by n times 4 to the n. Again, these go ahead and cancel. We are left with 1 divided by n. If you guys remember from our previous video, this is a p-series problem. We can go ahead and test convergence that way. And the p in this case is going to be 1. And we know that if p is less than or equal to 1, the series is going to diverge. So that's that right there. And then we're just going to go ahead and rewrite our equation based off of what we found, converging and diverging. So we say -2 is less than or equal to x because it is included, it converges. And then that is less than 6 because it diverges.